All right, let's start. I'll be wrapping up resistance, and if time permits, I'll be starting circuits, Kirchhoff laws. Okay, Kirchhoff's first law, second law. Right. So screen যেটা দাও, what I discussed last class. I'll go through this one more time. Important to finish. Why resistance decreases as temperature increases for a thermistor. So that's this. Right. So screen it too. Let's start. So can you tell me what's the transport equation? At a barber recap. What's the transport equation for a circuit? Yeah, I equals to n a qv, and আমরা যেহেতু এখানে একটা circuit with the wire নিয়ে কাজ করতেছি, the q is going to be what? E. আচ্ছা, but confusion যদি না হয়, q and e are same. So this is the formula, I equals to n a qv. Now the n that you see here is basically the charge carrier density, number of free particles per unit volume. A is the cross sectional area, q is the charge of individual electrons or charge carriers, v is what? Drift velocity. আচ্ছা, so আমাদের যেটা explain করতে হবে কেন তোমার হচ্ছে resistance কমে যায় for a thermistor if the temperature increases. So if you have a thermistor and the temperature increases, why does the resistance decrease? Because it's actually opposite to what happened in filament lamp. So if we go back to filament lamp to recap with a shape. So you have I equals to n a q v. Filament lamp as temperature increased, can you tell me the sequence of events that took place? So temperature increase করে, as a result a equation কি change হয়? As temperature increases, right, for a filament lamp, what changes in this equation? Drift velocity, right, increases. Why? Right, because the charge carrier is more obstruction from the positive line and vibrate more vigorously, right? So as the velocity decreases, charge same, area same, number of particles same. What happens to the current on your circuit? Decreases, and a decreases current implies that the what circuit has increased resistance. This is what happens for what filament, right? But আমাদের filament lamp we have already discussed. আমাদের আজকে দেখতে হবে for a thermistor, why is it opposite? যেটা হয় temperature right? And that has to do essentially what of the thermistor. Tell me what property of the thermistor is responsible for such a odd behavior. And right. So the charge carrier. What happens is intersequentially as temperature for a thermistor increases, right? Tomar cross section area change হয়? No. So that's constant. Does the charge of individual charge carrier increase? No, there's still electrons. So what happens to the drift velocity when the temperature of the material increases? decreases. There's no alternate to this. Cannot temperature barley, the positive ions will be vibrating more vigorously, so they will slow down. Acha, so it to slow down for it. Velocity decreases. However, thermistor is made up of something called a semiconductor, and semiconductor property hoche, as you provide energy to them, right? The semiconductor, what do they do? Sorry, it becomes metallic. Yeah, so what does that mean? Acha, are two different Okay, I mean, close. Acha, I'll explain this in very simple terms. Silicon, that's what thermistors are made up of, right? Do you know what the valency of silicon is? Silicon is called a metalloid, like a staircase element. Do you know what a staircase elements are? Like carbon, silicon. When there's this place where their valencies are what? 4 plus 4 বুঝো valency. So plus 4 যদি হয়, is it a metal or is it a non-metal? Plus 4 যদি হয় metal. Acha, okay. Anyways, it's that's the right term. It's a metalloid. It can do both. Acha, it can give electrons, it can take electrons, because here's the thing. Plus 3 hole, it has a positive tendency. Minus or plus 5 যদি হয়, it has a negative tendency because there's too many electrons out there. But 4 is the bridge way. কারণ 8টা তো হলে full octet configuration, right? So it's neither like going to take 4 or give 4. It can do either, right? Not our concern, by the way. Our concern is silicon, right, has 4 valence electrons. 4 valence electrons, typically speaking, right? How many of these valence electrons are helping you conduct? 0. None of them are helping you conduct normally, right? But when you provide energy to silicon atom, like a silicon atom ke jokhon energize koro, these electrons, they move out from the silicon structure and they move to which part of the atom or which part of the material, the delocalized place, where they can start to what now? Conduct. So every silicon atom, right, releases 1 or 2 extra electrons to the conduction band. Suddenly, what increases for your material drastically? N key, the charge carriers out there. It's like the logic is very simple. Think of like a sponge, and sponge ta bhitor pani ase, but you're not doing anything to the sponge, right? Is there water there? Yes. No, sponge bhitor pani, it's a soaked sponge, right? Once you press it, doesn't the water flow out of it? Silicon does that kind of a behavior. Once you increase the temperature of silicon, right, suddenly ki ber hoye ashe puro jinish theke electrons, plenty of electrons, and those electrons help you undergo what? Conduction. So suddenly your N increases, and it increases in what magnitude? Exponential. Acha, so tomar velocity kintu kombe definitely because of obstruction, and velocity decrease korbe maybe 10%, 20% maximum. Your N increases 5,000%, 500 times. Okay, it's a crazy increase that takes place. So when your N increases drastically, right, I'll put like double arrows here. What's the overall change for I? Should they increase or decrease? Increases, right? So I is suddenly very high, and an I that is high corresponds to a R that is what? Low. Okay, so that is what happens in semiconductors. So semiconductors ki hoy, temperature barle N ta change hoy, and N ta change hole N ta bare, and that's where resistance kome jay. Okay, the material property changes. Clear about this? Now there are 2 kinds of materials that do this behavior, or two components in our syllabus. Something called a thermistor, and the other one is called an LDR. Light dependent resistor does the same thing, but the electrons are triggered by what? Light. And there's this thing called a photoelectric effect, or hamper kore. We don't need to know that, it's for our A2. But light porle electrons ber hoy in an LDR, right? Or for a ki dile hoy heat, thermal energy, right? Both cases resistance ki hoy decreases because it's been introduced to your system. Clear about this? Now, এই দুইটা component নিয়ে আমাদের অনেক headache হবে future, আগেতে বলে দিলাম, the LDR and the thermistor, because they create circuits called the potential divider circuits or the sensor circuits. Some of the old levels partly ছিল যে ধরো একটা fixed resistor আর একটা thermistor, আবার ওটা পাশে একটা LDR, and light intensity বাড়তেছে, temperature কমতেছে, what happens to the lamp? Do you remember questions like that? Once in a while ashto, A level say it's staple, every other year ashbe. So you have to have a very good grasp of how these resistances vary, and it's an O-level thing. The temperature barle resistance kome, light intensity barle resistance kome, but these are only for LDR and thermistor. Resistor jonno though temperature barle resistance ki hoy bare. আর ওমিক কন্ডাক্টরের জন্য temperature change হয় না, তার জন্য resistance কি থাকে? Constant. These are the four components we have. Okay, so yeah, আমি answer তো লিখে দিয়েছি এখানে, last class discuss করতে. I'll just go through it very quickly. As temperature increases, the resistance of thermistor decreases. This is because as temperature increases, the number of charged carrier per unit volume increases drastically. Students sometimes say number of charged carriers increase, which is not wrong, but n kintu charge carrier na, n ki? Yeah, density, right? So I've seen in the Mars scheme that they say that charge carrier per unit volume has to increase. So you have to mention that, okay? Drastically. There's a small decrease in drip velocity though because of the obstruction, but that's negligible compared to the exponential increase in n. Hence I increases and R decreases. Okay? Is that clear? আচ্ছা, এখান থেকে দুইটা গ্রাফ আসে তোমাদের। গ্রাফগুলো একটু ডিসকাস করে নেই। So this graph that you see here, this is the what graph for a thermistor. So this is a graph for a thermistor, but graph to কিসের graph? Yes, very good. এটা বুঝতে হবে। I've seen a lot of students struggle with recognizing key graph চাচ্ছে. This is an IV graph for a thermistor. আচ্ছা, মানে current versus voltage graph. IV graph for an LDR exists করে না। কেউ বলতে পারবো কেন? But if you do have one, it's very random. There's no actual system to it. So why does an IV graph not exist for an LDR? Kind of close, but I don't know a reason. Well, why is there no consistent variation in an IV graph for an LDR? Right, under constant light concentration কিছু হয় না কেন? আচ্ছা আমি বলি, এটা একটু strange, এটা কোনদিন জিজ্ঞেস করেনি, but I want to clarify. LDR, right, behaves exactly like a normal resistor. When you provide what to it? Voltage and current, and you increase it. কেন বলি? When you provide very high voltage, a lot of what passes through your LDR? Charges. And what does your LDR start to become as a result? Heat up. And then heating এর জন্য যেটা হয়, এটা normal lamp এর মতন behave করে. So temperature বাড়লে resistance কি হয়ে যায়? Increases, right? এখানে হিটটা electrons কে trigger করে না LDR এ. What triggers the electrons? Light. আমরা light change করতেছি না. So without light change, right, the graph for an LDR is the same graph as what? A filament lamp. Okay, what introduces variation to your LDR graph? Light intensity. I or V কোনটা change করলে light change হয়? কিছুই না। That's why you see nothing. Okay, do you get my point? But thermistor কেন হয়? Because thermistor তুমি যখন হচ্ছে voltage বাড়াচ্ছো, current বাড়াচ্ছো, what does the thermistor start to do? Heat up, and heat triggers those electrons. Clear? So you'll never find an IV graph for LDR. That's the reason behind that is just a normal wire. It only interacts with what to create variation? Light, which is not in this graph, right? তার জন্য কিছু হবে না। So LDR এর জন্য কি গ্রাফ আসবে? LDR এর জন্য এই যে গ্রাফটা আসবে, যেটা thermistor এর জন্য same graph. I'll just quickly go through it. So LDR এর জন্য this is light intensity versus resistance versus light intensity. Light intensity unit key? Intensity unit? Watt per? Meter square or meter? ঠিক আছে, part of your syllabus. আচ্ছা, anyways, এটার গ্রাফটা এরকম দেখতে হয়. It's basically temperature বাড়লে resistance কমে and it decreases at a decreasing rate. Okay, so it's the same graph for your thermistor as well. It's provided in your notes, so don't worry about it, but I'm just বুঝানোর জন্য দেখাচ্ছি আরেকবার. All right, this is the graph for an LDR. So this is the R versus light intensity for an LDR. Question, how can you vary the light intensity on a resistor? Tell me multiple ways through which you can vary the light intensity falling on a resistor. Well, that's very advanced, but yes, you can do that. You can use not just polarized light, double filter. First filter place করবা, তারপর second filter place করবা, তারপর second filter কি করবা? Rotate করবা, তখন light intensity vary হবে. That's one way, right? Can you give me a much more primitive way, which is something that you can expect in your practicals? Distance. আচ্ছা, এটা খুব common একটা experiment যেখানে হচ্ছে মানে in theory, practice হচ্ছে আসতে পারে. They'll give you an LDR, they'll give you a light source. Light source থেকে যত কাছে নিবা brightness বাড়বে obviously, but brightness কি বাড়তেছে or intensity বাড়তেছে? Intensity. Yeah, brightness যদি power consider করো, power কিন্তু lamp এর বাড়তেছে না, বাড়তেছে intensity, because intensity always what relationship with distance? Inverse. inverse square law. মানে তুমি distance double করো intensity 1/4 হয়, triple করলে 1/9 হয়। এগুলো যদি কিছু না বুঝে থাকো, it means you have not been studying. These are all waves. Okay, we have done them like 3 months back. Acha, that's actually a good question. Can you tell me what if I change my color, right? Would that affect the resistance? Why not? Color change করবো, blue, red, green, yellow. Acha, okay. So it's a very complex branch of physics. A2 তে যা শিখি আমরা, frequency has no impact on light intensity, and resistors react to light intensity, not frequency. So আমার যদি একটা 100 watt red light থাকে আর একটা 100 watt blue light থাকে, who gives me more energy? Same, right? So at the end of the day, the resistor is reacting to the energy it gets, not the color. So color matter করে না. So filter দিয়ে হচ্ছে color change করতে পারো, but এখানে impact হয় না. More waves, but the energy is in the amplitude of the waves. Okay, so আমি যদি যে এটা করি high frequency, right? And if I do this, কোনটা বেশি energy? Secondটা, right? But frequency কোনটা বেশি ছিল? প্রথমেরটা. If you do this, it's a very high frequency. Barely শুনতে পারতেছো। কেন? Energy কম, তোমার কাছে যাচ্ছে না। হ্যাঁ, amplitude কম, but এটা যদি করি frequency বেশি না কম? But তুমি শুনতে পারো, right? কেন? Then the amplitude is very high, so it can travel to you before it dies out. Acha, so let's move on. Are you clear about these? কোনো question থাকলে আমাকে বলতে পারো। আজকে I'll be doing something that we have done before, মানে before as in like O levels, but তার আগে I want to clarify something. ওইটা হচ্ছে yeah, page 88. The IV graph for a diode. Right. So what's the current versus voltage graph for a diode? Let's see. এটা মনে থাকা উচিত তোমাদের, very distinct একটা graph. Right. So screen it too. বুঝি আমরা। The symbol for a diode is this. It's a triangle with a line in the front like that. And the diode allows conditional passage of current through your circuit. মানে হচ্ছে based on the direction, it'll allow current to pass through, right? So if your circuit is set up in a way that the diode allows the current to pass through, there's a name given to that circuit. What do we call it? Forward. আচ্ছা, okay. Right second. Draw করে নি। তোমরা বলো এখন। এই যে will the circuit function? Will there be current in the circuit? No. Okay. ধরো আমি এখানে ammeter place করলাম একটা, so I got my ammeter here and I have my ammeter there. Okay, so can you tell me ammeter 1 or ammeter 2 মধ্যে which one will show current? None at all. Wouldn't current like come halfway here and realize the door is closed? No, that's very good. It's one of the worst mistakes you can do in circuits, that you think that current has like passage halfway through. It can't do that. কেন আমি বলি, এটা যদি এরকম থাকে, my current is going to flow from where to where? Plus to minus. So যে কারেন্টটা এদিক দিয়ে যাবে, তারপর এদিকে আসবে, তারপর এখানে আসার পরে it's blocked. But that's how you think, right? But for a current, এই ব্লকেটটা মানে কি? There is no complete circuit available. So the current doesn't even start at the first place. There's no current flowing through the circuit to begin with, because এটাকে বলা হয় reverse biased, and reverse bias is just same as having what in your circuit? A cut. And if you have a cut in your circuit, right, is there any possibility current can flow? Absolutely none. Okay, because our current flow করার কিন্তু main reason হচ্ছে the other terminal is pulling my electrons or my charges, right? এটা cut থাকা মানে কিন্তু the other terminal doesn't exist. So there's no reason for these to come out, right? So yeah, this is called reverse biased. তোমার হচ্ছে সার্কিটটার নাম reverse bias basically means that the circuit is set up in such a way that current doesn't flow. Okay, now obviously the opposite one is referred as what? Forward bias. Forward bias মানে এটা তোমরা কি বুঝো what I'm doing here? এগুলো কিন্তু আমি কিছু নতুন শিখাচ্ছি না, just O levels এর recap করতেছি। আমি তোমাদেরকে আগেও বলছি যদি নতুন কিছু থাকে I'll make it very clear this is new and you need to be careful about it. So far just I equals to NAQB has been the new thing we have done, nothing else. So this is called forward bias or পাশে থেকে বলা হয় reverse bias, right? Now we have found that bias এ কোনো current flow করে না, it's very clear. Okay, forward কি হয় current flow করে, right? But turns out that's not actually true. The A levels we need to learn that. So what I'm going to tell you right now is actually O level stuff, but A level is mandatory to need to understand what's happening. Okay, so the graph for a diode looks something like this. So I V আর আমি হচ্ছে কি করলাম reverse bias মানে পিছের দিকে সেন্ড করলাম। পিছের দিকে যখন আমি ভোল্টেজটা দিচ্ছি I'm basically giving what voltage to my circuit? Negative voltage, মানে উল্টা দিকে যেহেতু দেওয়া হচ্ছে, and negative voltage I find that the current is what throughout? Zero. Okay, কিছু হচ্ছে না, there's no charge flow at all, right? Current flow হতে পারে, but কতটুকু current flow হবে, কেমনে flow হবে, right? So forward what we notice current actually flow করে না। কেন flow করে না আমি বলি তোমাদেরকে। You'll notice current flow হচ্ছে না and then at a particular point it's called the threshold voltage VT, suddenly there's like a surge of current, মানে অনেক current চলে যায়, almost short circuit এর মতন হয়ে যায়, right? So it becomes like a perfect conductor, if you could say. What happened at that threshold voltage? So this threshold voltage value to jana uchit tomader jonno 0.68 or 0.7, that's the rounded off version, volt. Okay, question hocche why did it not conduct before this value? Perfect, that's exactly the answer. Okay, very good. So remember I told you silicon is a partial conductor and it's a conditional conductor, right? তুমি যদি right amount of energy provide করে তাহলে conduct করবে। How much energy do you need to provide per coulomb charge so that they can shift to the conduction band? 0.7 volts. Silicon এর জন্য 0.7, এটা like a fixed value for silicon. So whenever you provide a silicon atom 0.7 volts, right, the energy is enough to move the electrons where? To the conduction band. And what does it become then? A conductor. Or niche কিন্তু এটা পারবে না করতে। Okay, germanium art element আছে, which is also what diodes are made up of. Germanium, for example, is 0.3. I have to comment a minute. Okay, you have a question? Why doesn't it allow you the other direction? Achha, I can explain that to you, but you have you learned this in school? Just simple explanation দেই। এটা হচ্ছে something called the term is called doping. So doping is a process that artificially just basic idea. What they do is they take silicon, right? And they dope মানে কি করে ওর মধ্যে হচ্ছে extra করে আর material লাভ পায়। So nitrogen and phosphorus atoms provide করে। And by providing nitrogen and phosphorus, right, what happens is the electron, right, because these are there, the electron are not moved this way, but as the electrons come from the other side, right, they can end up the hole created by phosphorus. So phosphorus can hold create করবে, nitrogen can hold create করবে. You know what the valence of phosphorus is? 5, right? What's the valence of silicon? 4. So 4 and 5 gives you how much total? 9. Isn't that extra electrons out there in your structure? So the electrons from the battery will never move into that because there's nothing to provide to them, right? But if I take silicon and if I take nitrogen, what's the valence of nitrogen? Tomother 3, right? So silicon is 4 and nitrogen is 3. So what's the total number? Isn't there a hole available to fill up? Because I'm going to fill up a structure. 8, right? So তখন কি হয় হোল গুলোকে ফিল আপ করতে পারে। সো আমরা কি করি একটা ওয়েফার বানাই, এই সাইডটাতে উই প্লেস ফসফরাস, এই সাইডটাতে উই প্রোভাইড নাইট্রোজেন। সো উল্টা দিক থেকে যখন আসে ফসফরাসে ঢুকতে পারবে না ইলেকট্রনস, দে গেট ব্লকড আউট। আবার এদিক থেকে যখন আসে তখন দে ক্যান এন্টার ভেরি ইজিলি বিকজ দেয়ার ইজ আ হোল ক্রিয়েটেড। And once the electrons enter here, phosphorus tells cello electron allow for it from the other side. But it's much more complicated than that. But the idea is this is artificial. Naturally that silicon naturally ulta dike allow korbe is not true. It can manipulate korte hoy, and that's what a diode is. Okay. Anyways, main idea হচ্ছে forward কি হচ্ছে forward যেটা হচ্ছে you have your 0.7 এ কোনো কিছু হচ্ছে না until 0.7, and after 0.7 it starts to conduct. And I don't know if you know the origin of this, like what I just showed. This is the origin of computing. Computers, so we use silicon, and the reason why we use silicon is because computers, right, require a high state and a low state, known as a 1 and a 0. And a 1 and 0 kore computing kora hoy. There's nothing else a computer does, right? But then 1 or 0 korte gele je problem hoy, previously amra 0 korte hole amদের pura circuit off kore dite hoto, and the information in the computer would be lost. But ekhane you can notice I can keep my circuit on but yet have what voltage or current? 0, right? So from 0.7 from 0 to 0.7, what is my state of current? 0. 0.7 upre gele, what is the state? 1. Mane current flow korteche. So when you have transistors, like a trillion transistor processor, each transistor is like a small diode. Ogla ki tumi jodi hocche 0.7 volts dao, right, or more, they become on. 0.7 volts er kom jodi dao, what do they become? Off. And by making them on and off, what can you create? The computing binary logic, right? That's why we use silicon in computing, okay? As opposed to something else, right? Like copper use kori, copper on kokhon hoy right away, or off kokhon hoy puro jinish off kore felte hoy. So therefore you can't create states, hold kore rakha jay na. Tomar circuit off kore dile to sob kichhui chole gelo, right? That's why we use silicon, germanium, a type of material for computing. Okay, that's the origin of it. Anyways, etake bola hoy forward biased. This is the place where your current is allowed to pass through. Well,
so the processor is the heart of the computer. So processor can output the decision voltage from 0 to voltage from above threshold to
the software. So if you just have a processor and you provide current to it, right, kichu compute korte pare na, because then there's no instruction provided. Instruction provide kor jonno there's a system called an ALU. Basically, it logic unit, right? So it provides information, the most basic form of it. Ota complex hote hote microprocessor where you have more processing going on simultaneously. Right, so this is forward bias and this is called reverse biased. Reverse bias কোনো current flow করে না. However, disclaimer, একটু দেখো এদিকে, পরে আবার বলবো যে এটা দেখানো হয় নাই, এটা অনেক বইতে পাবো, অনেক সময় টিচারও বলবে এই একটা গ্রাফ এক্সিস্ট করে, আচ্ছা, এই অনেক কেসে। সো গ্রাফটা এখানে এসে এরকম করে স্ট্রেট একটা লাইন হয়ে যায়। What is this? So this is known as the breakdown voltage. Breakdown voltage কি বলি? তুমি যখন reverse bias দিবা and you're sending all the electrons to pass with the পারতেছে না, right? Because they don't have enough energy. There is actually an energy available that will break the diode entirely. When the floodgates clip or not, like everything just overflows. So there's actually a voltage like that. What you call a breakdown voltage. That's why whenever in lab you're using a diode, which I've never seen in your lab, by the way, diode mode at rating দেওয়া থাকে, like 10 volts. So student মনে করে 10 volts monitor maximum positive capacity. It's not the positive capacity. It is the maximum what capacity? Reverse capacity. Karon 10 এর বেশি যদি যাও, what would the diode do? Breakdown. And unfortunately, this breakdown is a what process? A permanent process. Diode নষ্ট হয়ে যায়. It's not like you can reverse it. The 10 এর কমে চলে যাবে and the diode becomes normal. It's not like that, okay? So this is called a breakdown voltage. It completely ruins the artificial manipulation we do when you provide this voltage, okay? Not in the syllabus as far as I understand, but just to be safe there, this is called the breakdown voltage. Right, so that's the graph for your diode. Just to copy because I want to start resistivity. Is this the graph for the second circuit? No, these are both circuits simultaneously, because to achieve the reverse bias, right, you have to go in the negative direction, and to achieve the forward bias, you have to go in the positive direction. 5 sets. Are you guys done? Sure. So I'll start the next one. So I'll first quickly go back to the list and tick out the stuff done because মোটামুটি resistance এর main partটা শেষ. So define resistance. এটা আমি লিখে দিচ্ছি পরে. V equals to IR formula দেখছি. IV characteristic of ohmic conductor, semiconducting diode, and a filament lamp. We have done that. Explain the resistance of a filament increases as current increases with temperature. We have done that. Ohm's law, let's see. Understand that the resistance of a light-dependent resistor decreases as light intensity increases. We have discussed that. Understand the resistance of a thermistor decreases as temperature increases. It will be assumed that the thermistor is a negative temperature coefficient. You hear this sometimes, negative temperature coefficient. It doesn't really mean much. It just thermistor actual নাম data, NTC thermistor, negative temperature coefficient মানে it's a negative relationship with temperature. Temperature বাড়লে resistance কি হয়? কমে. Our normal wires are called PTC. positive temperature coefficient, right? Temperature বাড়লে resistance কি হয় বাড়ে। So ওই NTC PTC না বলে you can just call them thermistor অন্য কিছু করে না, like there's no PTC thermistor out there, okay? So anyways, we have discussed that. So যেটা বাকি, actually honestly বাকি না, মানে we have done this in O levels, but we need to go through this again here. It's the resistance equation, rho L by A, okay? O levels একটা problem ছিল, O levels IGCSE students there, এটা just qualitative relationship ছিল, like R is directly proportional to L, inversely proportional to A, and GC তে the whole thing was there, right? So আমাদের পুরোটাই করতে হবে। So ওটার জন্য হচ্ছে there's a page here. Can you go to page 90? আচ্ছা, একটু এক্সপ্লেন করে জিনিসটা quite interesting actually কি হয় এখানে। So সবাই স্ক্রিনে, when people did the experiment to find the variation of voltage and current across components, right, they found that the IV graph at a constant temperature gave you what? A straight line passing to the origin. Do you guys remember, right? A straight line passing to the origin. This is an IV graph. So what does the gradient of this graph give us again? The gradient of this graph, yeah, it gives us 1 by R, right? So এখান থেকে আমরা R টা বের করি, but the original story behind this is not that actually কি হয়েছিল? So actually যেটা হয়েছিল, they found like Ohm's law, right? Ohm's law they found that V is proportional to what? I, and proportionally বের করার জন্য you need to introduce what? A constant, right? So they did V equals to Ki, and this constant was the resistance constant বলা হতো, or I think it was called conductance, that was the right term, to conduct করতে পারে। But then eventually they realized that this K here is not just some random constant, it is actually a property of the material based on the dimensions of the material. So what I'm trying to say here is that this is not just a random number, this number can be traced back to what? The materials, like actual physical properties. So কি property উপর এটা eventually depend করে। So this K turns out to be related to the what of the material, the cross-sectional area of the material. মানে তুমি যে materialটা use করতেছো ওটার actual cross-sectionটা has an impact on this, okay? So cross-sectionটা, it also depends on the what of the material, length of the material, and it depends on a constant of the material or a property of the material that determines how much it allows the charges to flow through, which was eventually called resistivity, right? And then once we place R, or once we place these values of rho temperature resistivity into L is the length of the conductor divided by the cross-sectional area, we found that they all together gave us what value? The K. Remember the K, right? And eventually they realized this K is actually a property of the material's behavior towards restricting current flow, and that's when they gave this the name of what? Resistance, okay? Resistance হচ্ছিল the official term is not resistance, inductance বলে একটা জিনিস থাকে ওইটার উপর বেস হয়, but anyways all levels we call it resistance. So resistance is actually key, it's actually the property of a material to obstruct or restrict the flow of current. Or একটু আগে একটা কোয়েশ্চেন ছিল না, ওই যে সিলেবাসে ডিফাইন রেজিস্ট্যান্স, রাইট? ওটা কেমনে ডিফাইন করবা? মানে এখানে আমি তোমাদের দুইটা অপশন দিলাম, তো একটা এটা আর একটা কি, যে V equals to IR. So if they ask you to define resistance, right, which one would you, what would you say? Would you say resistance is the property of a material to restrict the flow of current, or would you say resistance is the ratio of potential difference to the current in a circuit, or would you say resistance is the product of resistivity into length by cross-sectional area of material? Which one do you think is acceptable? Right, so actually it's all of them, they're all true, but the one they accept in your exam is actually V equals to IR. So R equals to what? V by I. So resistance is actually what, like by definition in your syllabus, the potential difference per unit current, and that's resistance, okay? So আমি তোমাদেরকে আগেও বলছিলাম এটা, I just wanted to reiterate something. What can you do all the time in your exam when there's a definition? Write the formula in words, okay? So whatever taken a problem, there can be two of them, that's why I want to clarify that is better, because that's what they allow, okay? So yeah, coming back to my equation here, এখানে A হচ্ছে cross sectional area of a wire, So cross section area বাড়লে তোমার হচ্ছে resistance কমে যায়. This is the length of the wire. And rho টা কি? Yeah, it's called resistivity. Resistivity unit কি কেউ জানো? Yeah, it's ohm meter, not ohm per meter. So it's like ohm meter. And people তোমার যদি বসায় একসাথে you find that the basic ohm চলে আসে. So yeah, the equation for what? The equation for the resistance of the material based on what property of the material? The physical properties, like physical attributes. Okay. Resistance is the actual value of what resistance is provided. Resistivity is the property of the material as a whole. So let me give you an example. Here resistance এটার রেজিস্ট্যান্স হচ্ছে 10 হবে আমি যদি এটা আরেকটা অ্যাড করি 50 হবে the resistivity for any amount of this material is going to be what constant. Okay, it's like density. So density into material is constant, but the more you have, the more what you have. Density যদি বেশি হয় like density কি হবে the more you have, right? What changes, density or something else? Mass or volume. Okay, মানে আমার যখন হচ্ছে একটা মেটেরিয়ালের I increase the amount of it, density change হয় না, কি change হয়? Mass and the volume. Okay, so this is your resistivity. Resistivity কোনো definition নাই মানে officially. If you want to know, it's basically the property of the material to resist. Okay, so R equals to rho L by A, and the other equation that we have here is this one, which is R equals to V by I. বুঝছো? Now কোনটা কখন use করবা? The one on the left is to be used when you're using what? Actual physical attributes like length, cross-sectional area. আর right এটা কোথা থেকে পাওয়া? From circuit values like current and voltage. So exam এ তোমাদের দুইটাই আসে. And I have already, it's in the book, but you'll do this eventually, finding the resistivity of material. করতে হলে কি বের করতে হবে? R, L, and A. To discuss create and একটা question জিজ্ঞেস করে প্রায়. So resistance কেমনে বের করবো? If I want to find resistivity, right? How do I find resistance? Yeah, you set up a circuit, right? You allow what to pass through your component current. ওটার জন্য ওইটা across একটা কি পাবা? Voltage. V equals I at the কি বের হবে? Resistance. So to find resistance, you set up a circuit, right? How do you measure length? What instrument? Meter rule, right? How do you measure cross-sectional area? Micrometer screw gauge. Naki. Very good. আচ্ছা আমি যে কোয়েশ্চেনটা করছিলাম ওটা কোনো অ্যানসার নাই কিন্তু you can't find cross sectional area of a material. You can not measure the cross sectional area of a material. What can you do? You can measure the diameter and then calculate what? Area. আচ্ছা it's a very important distinction. এটা বুঝতে হবে তোমাদের। কেন বুঝতে হবে? যে তোমাদের এমসিকিউ তে মাঝে মাঝে জিজ্ঞেস করে যে মেজারমেন্ট কি করা হচ্ছে, চারটা অপশন দেওয়া থাকবে। ওরা বলবে যে ক্রস সেকশন এরিয়া একটা অপশন আর ডায়ামিটার একটা অপশন। What are you measuring? Diameter. আচ্ছা be aware of that. আর ওই ডায়ামিটার মেজার করার জন্য what do we use? Micrometer screw gauge. বুঝছো কোনটা? আচ্ছা anyways, that's something I wanted to clarify. When is the left equation to be used? Left equation use করবো when we are actually given the wire and we are trying to find out what of the wire, the resistance of the wire based on the length and all the properties out there. Our right এটা use করবো কখন? When we have actual circuit available for us, right? So time tonight, but I wanted to do a ratio question. তোমাদের কি মনে আছে that we did like couple of months back deformation chapter যেখানে হচ্ছে two different wires were provided of different cross section and different length, and you have to find the extension. Do you remember? আচ্ছা আমি দেখাই আমি জ্ঞান বলতেছি there's a reason I'm gonna explain behind that. এটা আমরা এখানেও করছি, এটা আমরা হচ্ছে আনসার্টেনটি করার সময় করছি। Do you recall this question? যে দুইটা wire ছিল and they had like different diameter, different length, then we had to find like what was the ratio of their extension out there, right? Exact এটাই ওরা তোমাদেরকে হচ্ছে ইলেকট্রিসিটিতে দিবে, but instead of finding the ratio of the extension, you're supposed to find the ratio of what? Resistance. Okay, so এখানে যে লজিক গুলো ইউজ করতে হয় সবগুলো অ্যাপ্লিকেবল। যে ডায়ামিটার যদি হচ্ছে এখানে twice বাড়ে, এরিয়া কত টাইমস বাড়ে 4 times মনে আছে স্কয়ার হয়ে যায় so yeah just keep in mind যে this particular ratio math comes in 3 different places in your syllabus একটা হচ্ছে deformation একটা হচ্ছে electricity আর একটা আসে কোথায় uncertainty তে in order to find the uncertainty you have to apply these ratios okay so just letting you know আমরা next class এটা করতে হবে before I can move on so এটা হয়ে গেলে আশা করি next class I can start the Kirchhoff law it's complicated with that Oh, you did? Thank you.
Sorry, yeah, আমি তো আপনাকে ফার্স্ট আসলে বলছি আনসার্টেনটি তো পাই নাই আমার নিজের শিখা লাগছে সো অনেক কিছুই সো কাইন্ড অফ মিসিং সো সিলেবাসের শেষে আনসার্টেনটি একটা রিভিশন দিতে পারবেন
আমি সিলেবাস শেষ পর্বত হচ্ছে ফার্স্ট উইক অফ ফেব ওটা শেষ হওয়ার পরে I'll try to immediately start question paper so প্রত্যেকটা পেপার almost first question is uncertainty so আশা করি ওগুলো করতে গিয়ে I can help you out but you also raise your questions when I do that
রেশিও যেটা বললেন ওটা আমি
মনে রাখবেন আচ্ছা আশা করি we'll face